Hey everyone, welcome to our Tech Talk. I'm Daniel with GREE, and here with me today I've got Greg Bruntz. We're going to be doing an installation of a, what is it, Greg?
It's the new Gen 4 LIV. It'll be a 2.5 ton.
Okay.
Single zone, just inside and outside. So Daniel and I have been talking, and we thought, you know what better way to give you guys tips on things that we see phone calls into the technical department about installation where things go wrong. So, we thought if we do an installation, we can show you guys the things, the tips of the certain things that we want you to be mindful of when you're doing an install. To hopefully that when you guys go out and do your own installs, you'll remember what we pointed out to you to be careful about, so that you don't have any problems out in the field.
And the cool thing about actually doing it is we get to get our hands on it. We get to experience exactly what the guys that are calling us needing help are experiencing in the field.
Absolutely.
So we can give you some tips on how to get around some things that may be a little bit of a problem.
Neither one of us want to become contractors.
Right.
And be doing all this all the time. We
not
just
getting into that.
We don't want to take away your business. We just want to be able to provide useful information about the equipment. Right down to unboxing it, and that's what we're going to do next, because there is, believe it or not, there's some tips there that when you're unboxing things to be mindful of while you're unboxing the equipment.
Right.
So without further ado, I guess we'll just roll through and unbox this wall mount and get started on doing the installation.
Sounds good.
All right, so let's get this thing unboxed.
All right. So we've already got it
cut
accessible
open
here.
Yep.
You'll notice there's our wall plate.
Template. Yep.
Wall template. So we'll put that over here against the wall. One of the most frequently asked questions that we have is, where's my remote? It didn't come in the box, right? So you'll notice on this particular unit, the remote control is in the styrofoam packaging.
And believe it or not, people throw that styrofoam away and throw away the remote in it.
Yep. So we want to make sure that we go ahead and take the remote control out and set it to the side. And then we can put this piece of styrofoam under there and move on.
So the next thing we're going to be doing is pulling the rest of the styrofoam out to get to the actual wall mount itself. And then the easiest way to do it is just kind of, this is a big head, so 2 people is preferable. You get your hands underneath it, pull it out. Before we
throw the box away,
right, grab the other accessories.
Couple of pieces in here that we want to make sure that we
hold them up,
collect, and make sure we set those to the side with the remote control so that we don't lose those. We have the flare nut that comes in this package here, and also the remote control holder. Got a couple of batteries and some paperwork in there.
And the insulation to be able to wrap around the refrigerant lines after you do your flare connection.
Correct.
So Daniel, I'll hold the unit up here if you want to get the box out of here. So one of the things we did, we set this up on a table so we can, there's things here we wanted to point out to you. So, and it makes it convenient too.
On the front here, we have this you will want to save. So this is the end user guide. It's got a few notes about filter, cleaning the filter, some quick notes about the remote control, the use of it. And it also has a really cool little place for the contractor's business card on the back there.
Yeah, and one thing I want to point out with that too is, it's very important that you share that with them, because a lot of people that you're installing a mini split for have never owned a mini split before. So they're not used to those icons and how the remotes work and stuff like that. So any information that you can give them as a quick start. So in my opinion, in this scenario, where just a minute ago, we put the remote aside, this would be a point where I would stop. I would take this and the remote and take that to the homeowner and let them be responsible for where the remote is. Let them be responsible for reading over the instructions and stuff like that and how to operate the machine.
The easiest way I have found, you know, to get started with the installation. When I go to mount this on the wall, I want it apart.
So you take the plastic cover off.
I take the outer cover off and get it out of the way.
I don't
I
blame
also
you.
use that as a little bit of a reference to make sure that I'm within my template when I put hold just the cover up against the wall. That way I can see that I'm not cutting a hole or anything like that. But
Okay.
in this particular instance, we're running the line set inside
Correct.
of the garage, right?
Correct.
So we're not going to be cutting a hole directly through the wall.
But I actually kind of like the idea of taking the cover off too. A lot of people don't, but in my opinion, I like to take the cover off for another reason is I can set it aside in a safe place and it doesn't get nicked up, it doesn't get scratched or anything like that. So when you're finally you're done with the installation, one of your final moves is to put that cover on that's in really good, clean condition.
And also leaving the plastic cover on here until we are done, and that way it doesn't scratch the surface here. So we're going to unpackage this unit here, open the hood, and
I have no fingernails, so we're going to let Daniel do that.
Okay, just got mine done this morning.
Awesome.
Got a mani-pedi.
I don't like the color you went with.
Probably should have got the dirt cleaned out, huh?
Yeah, maybe. That's all good. Shows you're a working man.
All right, so we got the cover open.
There we go. Now we can get to the screws.
So we're going to have screws across the front, but we're also going to have a couple of screws underneath the louvers here. So we'll need to remove the louvers and get them out of the way.
So one thing I always cringe about when I'm on the phone with a guy on the phone working on one of these units, I always hear the impact.
Zip, zip.
And I will tell you guys, you know, there's something to be said about sticking with the old hand screwdriver.
Because sometimes you hear zip, zip, and then crap.
Or oops. Or sometimes you hear a little more colorful language.
Yes.
Let's go with that.
There's that.
Okay.
And we do have to take the display off here.
I heard you drop it.
I know, I got it. It's right there.
Look at that. You're good.
Right. Now, we undo this piece and get it out of the way.
There we go.
We need to take the louver out to get the beauty covers, right?
Yep.
So, take that off of there. And these just pop right out, just like that.
You can just take your time. You won't hurt them. All right, we'll get them out of the way too. I'll set them in the box over there with the rest of this stuff.
And then on this one, we've got four screws across the bottom. Move these beauty shields and put them somewhere that we can keep up with them.
I'm going to do the same thing with those. I'm going to give them a piece of tape along with the screws. Matter of fact, I can tape them right to this cover. We're going to pull the whole cover off. Then they won't get lost. And then when you got all the screws, I'll take those.
There you go.
Thank you, sir.
All right, now we're ready to take it apart. Now, since it is new, we've got some more tape covering the seams. Just shipping protection. We'll need to...
There we go. Now we ready to lift this off?
I think so.
What am I doing wrong here?
Should come right loose.
Well, something's not cooperating. It's caught right here on that last catch. He got it.
There we go. Make sure we get our display fed through.
Yep.
All right.
There we go.
Now we got that all out of the way. Now this one's two-piece. Unlike the smaller ones.
Yep.
Okay. So
I'm just going to go ahead and take this plastic off because it's going to just be in the way. Okay. So on this installation, the refrigerant lines are going to come out the right-hand side. So we want to get this thing rolled over where you guys can get a good look at it. We can form that refrigerant line. There's some things there that we want to be mindful of. I got this side. And Daniel, you're real good about talking to that, so I'm going to let you.
all right, so when we put this on the wall up there, the refrigerant lines are going to come out the opposite side of the way that they're facing right now, right?
Correct.
So we're going to need to bend those very carefully to make sure that we do not keep the copper lines when we bend them over. Now, the drain line's already on the correct side over there, so we don't have to move it. So we can go ahead and take the wall plate here off, right?
Yeah, I'm taking this sticker off real quick because the other thing we're going to want to do is we're going to have to pop this knockout.
Right.
So that's why I was taking that tape off of that side.
Okay.
So that would be easy to get that popped off to where we can, form them refrigerant lines. So.
All right.
All right, so let me hold the unit up while you get that back plate off.
Okay. And these are going to be a couple of extra screws because we don't need these. So if you do have 2 screws left over, that's where they came from. Lean it back a little bit.
Yep. There we go.
All right.
So, Daniel, what do you recommend for popping that knockout to get a really clean cut?
I would use sheet metal snips.
I would too.
Just to make sure it's nice and clean and it doesn't break.
That's the one thing that I didn't bring with us today.
Really?
But I have another plan.
Okay. What's your plan?
So, I think you'll like this. Just because I happen to have it with us. I think we can cut that pretty clean with this.
Perfect.
Because I can get right in them the slots
in the
there,
notches.
and I can.
Yeah.
There we go. That worked out perfect.
All right.
So we got this nice clean cut. So now we can talk about getting
Bending
the
the
refrigerant
line
lines
sets
bent
out.
around.
So,
Throw this tool out of the way.
now remember we talked about this clamp.
We have.
And this one's made a little bit differently.
Yeah, that
I'd like
was
to
actually
know-
screwed in.
Yeah, I'd like to know your opinion on this. I would personally take this off and discard it.
I would.
And that way, when I go to maintenance the equipment, I'll be able
Yeah,
to
because
actually
once it's
have
hung
some
on the
movement.
wall, you don't. That's more for shipping anyway.
Yeah.
So I'll go ahead and buzz the screws out of there. we've talked about that before, because if you ever got to get to the blower wheel, the blower motor, whatever, this is just going to give a little bit more free movement of the evaporator. And it also makes it better when you're bending these refrigerant lines around.
Now, on this, we're probably going to have some flexible line here.
Do we want to err on the side of caution?
I would err on the side of caution and actually cut this to where I can actually see it while I'm bending it.
Yep,
We've got plenty of tape that we can tape it back together with and seal it. So, probably about right there.
I'm trying to get a clean cut, but that blade's not very sharp. Sometimes if you just get it started and give it a little peel. So it is a flexible line, which is a good thing. But the whole trick is, and we've had plenty of these where that's kinked when they install it. So you want to be diligent about bending that.
All right, so, and also we want to secure this while we're doing it as well. So just kind of hold this. We can bend this out slowly.
Let me go on the other side of you so I can get a better hold of this thing. Okay, I got it.
All right. So we want to make sure this stays secure and slowly move it over.
Because that's quite the bend you got to make.
Yeah, we're going the complete opposite direction.
And if you got to tear more of that insulation to see it, that's fine. We got plenty of tape.
And there we go. So we can check the bend here. We're still good, so we can go ahead and tape it back up and make sure that we don't have any outside air getting to these pipes, because that will condensate if outside air gets to it or ambient air gets to it. So, all right, so bend this out just to here like that. So we've got some room to wrap it.
All right, so one thing that Daniel and I have both talked about is a lot of times guys in the field will tape this with like electrical tape, or and that's fine. Not saying that you shouldn't use electrical tape. The thing is, they wrap it too tight. If you wrap it real tight, you're pressing that insulation up against that cold pipe, and that's what causes it to sweat outside the insulation.
On the outside of the insulation.
Right.
Yeah.
So what you want to do is keep it loosely fit. And I have some of this flashing tape that actually is super sticky, as you can tell, that I think will work really good for this application. And I had a roll of it, so I just brought it. Because it's so sticky that it really just doesn't take much. You just kind of wrap it around there. All we want to do is get it taped back up.
It just needs to be sealed.
I'm going to pull this so that that
Together.
is more together, and I'll tape this first.
There you go.
And then we'll do that corner. There we go.
But that's going to seal it.
Seems to be sealed a little bit around. We got a little slice up there still. We'll cover that up. You ever cut your insulation, like where you're going to use your tubing bender or something like that? Same thing. Don't press real hard and tape that real tight. I was guilty of it myself when I was out in the field.
Come up further. Yeah.
Just make sure you're not, pushing real hard on that insulation. That insulation's loosely fit on there anyway. As you can see down here, that's real loosely fit on there. It's just got to keep it from, you don't want it pressed tight against it. So we're good there. Now that'll push in real nice when we hang that unit.
You want to make sure that the condensate stays on the bottom side of that.
Wire harness here. I think it's for a remote.
It's for a wire controller.
Yeah, a wire controller. That's what I meant to say. We want to get that down underneath there. Nothing's going to get smashed there or anything when we hang
make
that.
sure, take a look at your drain line, make sure that it's not kinked either.
Yep. And once we mount that on the wall, it's going to go flush and be nice, and nothing's going to get smashed or cut into. So, awesome.
All right, so it looks like
All right, so we can roll that back on its back so it'll sit until we're ready after we get the wall mount hung.
All right, so Greg is here on the ladder. We're going to get the unit placement measured out and marked. So we're going to start by measuring down 3 to 4 inches. The minimum distance from the top of the unit to the ceiling will be 3 inches. So we want to measure down about 4 inches, make sure we have plenty of space. And also, you want to make sure you have space to open the hood and get to the filters and clean those and maintenance as well. So what are we going to start with, Greg?
So I'm going to start with what I already did real quick. Was I wanted to know roughly where the center of it was. Mm-hmm. So the unit's 52 inches wide. So center of that would be 26 inches from center to the side.
Right.
So what I did was measure and make sure I was going to stay away from the garage door and stuff, since it's a garage install and there's a bracket and everything for the garage door riders, and we want to make sure we're past all that. So I did was I just put a little pencil mark, just enough to know where center is.
Right.
And that way I know where the machine's at. So now we're going to do exactly like you said. Go ahead and put a mark 4 inches down off of the ceiling, take the level, now we got a level line to work with, because these units, correct me if I'm wrong, we hang them perfectly level. We don't need to slope them toward the drain.
We don't want them sloped one way or the other towards the drain. We want them perfectly level because the drain pan is already designed with the slope.
Correct. That's what I thought. So,
yeah.
All right, so without further ado, let me do this. I'll mark this 3 inches down or 4 inches down. I'm going to go with 4 inches just to be on the safe side. Put me a little pencil mark there. Then I'm going to grab that level. If you wouldn't mind handing that level to me, Daniel. Just to give me a little bit bigger line to work with as far as level. And then I'm also, since that was center, I'm going to go ahead and put a T mark there, right at that little mark I just made, so I know that's the center of the machine, just in case I need to reference that further. And then I know I can go 26 inches both ways, so I can put a pretty good line here for level, because the machine's going to cover all that anyway. So now we're going to locate the studs, just to make sure we're hitting something solid. So I know I'm hitting one right in here. I can put a little mark right there because the unit will cover it. So I'm going to go ahead and run a screw in each one of these just to make darn sure we are definitely hitting the stud. Oh yeah, hitting it there. Definitely hitting it there. And definitely hitting it there. So we'll be able to get a good solid mount with that bracket.
Perfect.
So,
all right. So
since we're coming out the side, we really don't need the template. But I want to throw it up here a minute, just kind of talk about it. So when you put your template up, you can kind of do like I did and kind of, put it at your center mark there. And then if you take some tape and tape it up there, that way it stays in place, this gives you pre-marked holes for where you would drill if your line set's going right out the back on the right. And it also gives you a pre-marked hole for if you want to drill your hole for your line set to go out the left-hand side, either way.
And so, keep in mind on this template, the drawn lines on the top and the bottom is going to be your actual lines you want to stay within, not the cardboard itself.
Right, so actually I would want this up then, about a 1/2 inch. So what I could do is, if you really want to be real accurate, and probably not a bad idea, if you just measure what this is, then you'll know how much further above you need to go.
Right.
Of your line.
Or you may even want to, put a blade to that, just use an X-Acto knife and
yeah, or actually cut it off the exact height.
And that way you're not getting confused, because it looks to me like there's a little bit more cardboard on the left than the right. Then you could end up a little crooked.
So what you're saying is just lay this out on a board or something and cut with a razor knife
right
all the way down where the exact height of your...
Exactly on that line.
And that makes good sense.
And you would know you have to stay within those lines to where everything's covered and you don't have to...
Yep, and then you know your line set hole is going to be exactly where it's supposed to be.
Right.
So...
Now the other thing that I like to... I'll take that, Greg.
Sure.
The other thing that I like to point out now, if you look at this, it doesn't appear to me, if you look at the template, got a little bit more room on one side than the other, maybe?
Yep.
So your actual bracket is not center.
Yeah.
So
that's true.
If you plan on your bracket actually being the center, then you're going to be off a few inches one way or the other. And
I measured for center, so I'm glad you brought that up. So let's do that real quick. Take the tape measure. No, throw that up here a minute. And measure from that center to what it's going to be on my right-hand side, or your right-hand side. That's the left side, right side.
All right. So on the right-hand side, we have 10 1/4 inches to the bracket.
What's at the center from the right side?
And then to the center of the bracket, we've got 25 inches.
Okay, so I'm going to be an inch off.
An inch off.
So I measured 26 inches to where my end of, which in this application it's going to be fine, because all I want to do is make sure I was well clear of the garage door.
Right.
And the bracketing for the garage door, so that we're not throwing air over the garage door.
But if you were up against, close to a frame of some kind, door frame or, a window frame or something like that, if you're an inch off,
that could be a big deal. Yeah.
It could make a big difference.
So for our application, like I said, since we're bringing the line set at the right-hand side, we don't really have to use the template. All we need to really do is mount our bracket. So we can go ahead and get our bracket up there. And this you would put perfectly level and center. And then I'm actually going to cheat it over a little bit. Reason being is my stud and my center mark are where I was going to be is about 1/4 inch off. So I want to be able to put a screw dead center and be level on my bracket. So I'm actually going to put a screw in right there. Go ahead and load me up.
There you go.
And we made sure we pick screws that's got a decent head to it. There's no way it's going to pull through the bracket. Now the other thing I want to do, and right in the side of my tool bag is my little bullet level or torpedo level. Mm-hmm. So before I put these other screws in, I want to make sure this bracket, even though I drew a line up there, I want to make sure this bracket, that's why I put the screw in the center first, so I can teeter-totter it and make sure it's perfectly level. That looks really good right there. And we're perfectly level right there. So now we can go ahead and put a couple more screws in here. Now we're going to miss our studs completely over here, and we're missing our stud completely over here. So the more I think about this, again, because I know it'll cover, and that's why I didn't make my pencil lines the full width of this thing, I think it might be in our interest to move this over a little bit to where we grab at least 2 studs.
I agree.
Instead of grabbing just 1.
Yep. So
we're going to redo this. And I think on this one, I'll just go on the right side. And I'm going to put this right where that I know that stud's at, down on my line. I know I grabbed a stud there. And then I can move this up. I know my stud's here. You want to hand me that pencil? I'm going to make this line just a little bit longer so I know where that stud's at. Make sure we're level. And we are. And we are. So, I really don't have a good slot. So I'm just going to go plumb through the metal. Now, if you notice, I snugged that in, but I didn't really hammer it in tight because you don't want that plate to be wavy because then the head won't hang on it flush. So, that bracket's pretty tight. But I think we can get another screw down here a little lower.
If you can get a screw, if you can get it fastened towards the top and also at the bottom, then it holds it flush against the wall a little bit more when we actually hang it up there. So
I know right in here I can grab another and still hit the stud. Oops. I was pinching it too tight. I didn't want that.
Yeah.
If you want to grab me another screw, I'll get another one up higher up here. Now we don't have a stud there, but we could use a drywall anchor behind that and put a couple screws in there just so this is not flip-flopping. Same with that one. That's perfect right there. Good deal. Stayed level. Yeah, it moved on me quite a bit that one time. When I first put them screws in. Not exactly sure how it moved on me, but it did.
You didn't hold your mouth.
I hear you. I probably didn't. All right. Run these screws in. Thank you, sir. There we go. Brackets level. We're ready. All right, now we'll move on to getting the unit up here, huh?
I think we're ready.
I think we'll break out those mighty brackets. All right. All right, so this little doohickey goes on here. And open the bracket up. Bring it over and hook it right on there. That looks good. Take this one. Oh, good, you already prepped that one for me. Go ahead and open that up. This should hold it. Good deal. All right, now we can get that unit lifted up here.
All right.
Let me get this drill out of the way.
You want me to walk it up there?
Well, I think if you can pick it up and turn it around,
Yeah.
and then you can hand it up to me, and I
Okay.
should be able to set it up there. Just keep the right end and walk to your right. I got the left end.
Okay.
Okay, give me 1 second. I got it.
You got it?
Yeah.
Sure.
Yep. There we go. And then I can slide it forward. And let it rest for a minute. So I can get more prepared.
And you want to be careful with the coil.
Yeah, it's so gently leaning up against it. I
Yeah.
don't think it's hurting it at all. So I think at this point, Daniel, even though we ain't ready to run the line set and stuff, since it hangs, the line set's going out the side anyway, we can go ahead and get the wire and get it poked up through it, so the wire can just dangle, and then we can go ahead and hang it,
I agree.
and we'll be able to get the mighty brackets out of the way.
Yep. Because this cable come with the line set, I'm just going to do a quick check.
Okay.
Make sure, just looking at the rating on it, it's 14 gauge, 600 volt, stranded.
That's what we want,
That's
right?
exactly what we want. We're good to go. A lot of times I'll see like the smaller cables like this. Usually they're gray. It'll say mini split cable on it, but
Right.
it won't have the voltage rating. If you look up the spec of the manufacturer, it'll say it's 300 volt rated. That's going to cause us some problems.
But-
Maybe not right now. It may work.
But
you
very
know.
well, we've had calls
We've
with
had many
communication issues with 300 volt
Yeah.
wire.
Yeah.
So, and when they're talking about that 300 volts or 600 volts, what they're talking about is the insulation class of each wire in that bundle. And the 600 volt rating means it's got better insulation around it.
Right.
And what happens is if you have a wire that is not got enough high enough voltage rating, what can happen is you get voltage bleed from one wire to the other. Now, it's not a direct short or anything like that. You're not going to pick it up with an ohm meter or anything like that. But doesn't mean the wire's not compromised for communication. The other thing you want to be careful about when you guys are running this wire is that you're not pinching it, kinking it, or making, real aggressive type bends.
Right.
Because now you're compacting that wire where you made that real tight bend, and you could actually be causing that to give you that voltage
That
bleed across those insulations.
the different wires.
If you staple the wire, I wouldn't staple it. What I've actually seen a lot of electricians doing now, they don't staple the wire in a lot of instances anymore. They use wire staples, and they hammer that into the stud, and they zip tie the wire to the staple
Oh, really? I haven't seen that.
instead of actually nailing the wire.
Oh, okay. I like that.
So it's a good help. I thought it was a great idea.
Yeah.
So that will help you from compromising the wire too, because if you staple that wire and you pound that staple a little bit too deep, you're smashing
pinching
that
it.
wire,
You're
you're
smashing the
pinching
wire.
it, and you could be compromising the voltage rating
Right.
on the wire.
Right.
Again, you won't pick up a direct short, but it can and does compromise the wire. So, all right, I'm gonna climb up there and chase that wire through the backside there. Right here. And just poke it out the front and give us enough that we know we're not
plenty
going to
to work
have any
with.
issues to hook it up. All right. So, one thing I did notice is that wasn't screwed on the bottom.
kind of pulled it out a little bit.
It's pulling out on it.
With the
So
Mighty bracket.
I think what I'm going to do, even though the unit's sitting up here on the Mighty bracket, I'm going to run another screw in there to pull that bracket tight.
Okay.
Because I just think it would be the smart thing to do.
Well, the thing is if it's been out a little bit like that, when we go to put the unit against the wall, it's going to have a little gap between the unit face and the wall.
It ain't got to be super tight.
Perfect.
But that pulls that bracket up tighter now. All right. So I did dent the coil just a little, but not enough that it's going to hurt anything. So, Daniel, since this unit's so big and awkward, I think it might be beneficial to get another ladder up here.
Okay.
And we'll work together and lift this thing up onto the bracket.
Okay. So, wait a minute. We got 4 slots. We only got 3 up there.
Well, you're hanging on 3.
Okay.
The heaviest side's over here.
Yep.
Right. So we get on there?
I think so.
Hard to tell.
It's on there. Yep.
All the way around?
All 3.
All right, cool. So we can pull the Mighty bracket out?
So I'll hold this forward a little bit. Pull the Mighty bracket out of there. All right.
And then you want to double check all that, make sure when we go down we're not pinching nothing.
So we've got our wire right there. Yeah,
We are good.
good. Yeah, so we can snap it.
I like that. It's nice and flush. All the way. It looks good.
That's the important piece of making sure that the bottom of the bracket is mounted well to the wall, even if it's just with the drywall fastener.
Right.
Because otherwise, this here, it won't be flush. You'll, especially from the ground, looking up at it, if it's higher than eye level, you're going to see that gap and it doesn't look so great. So, and the worst thing in the world is putting silicone around it. It
Right.
just looks terrible. So
I'm going to let Dan, just to all that's watching, Nick, our camera guy. So down across the bottom of this unit, I think you can get a camera on it, but kind of repeat what Daniel was just talking about. So when you hang these wall mounts, and you had that bracket down here on the bottom that we had the Mighty brackets hanging from.
right.
What Daniel was saying was it's very important that you get them flush. And remember, I added that screw to pull that bracket in tight. So that gives you this nice, clean, flush look to the bottom of the unit because it hits the wall properly. Again, that's what I was stressing about not over cranking those screws, because if you cause a wave in that metal hanging bracket,
You will see it.
you're going to see it out here on the finished product.
Right.
So you don't need to run them screws. There's no countersink in here. You just need to make sure the unit ain't going to fall off the wall. And then lastly, with the Mighty bracket, when they're hanging on there, if for some reason we allow that to put too much tension on that and bend those brackets downward a little bit, you may have to bend them brackets back up a little bit so the bottom actually locks in tight and pulls
Right.
it to the wall. So, and then another thing what Daniel was saying was, some guys will come back and put silicone around it and it just looks terrible.
Yeah.
You shouldn't need any silicone around it. So and as you can see, all the pencil marks that we made on this wall is all hidden by the unit. So, don't be afraid to, once you know where your unit's going to be sitting, roughly the dimensions, mark your studs, run a screw in there, make sure you're actually hitting a stud. And then, when you're all done mounting the bracket, do just like I did. Make sure that bracket stayed level. If it got out of level, unscrew it, rescrew it, make sure that thing is level. Because the last thing you want to find out is the bracket slipped on you or something like that when you were installing it, and now the unit's not level, and now we got water running off the left-hand side here, or in the middle, or something like that. So it's very, very important that you got these units hung level. So with that, I think we're ready to move on. We can.
Well, I'm excited to see how our line height turns out.
Yeah, I think it's going to look good. So we can start getting line height up on the wall. We know and start spotting for where our refrigerant lines are going to go out the wall. The homeowner here, we could have went out the back wall and done the line height outside, but he said, since this is his garage and just the look of the house, he'd rather use the height line inside, so that's why we're doing it on the inside. So,
which I think is a good look.
Yeah, and you'll kind of see how we go about doing all that. So, all right. That looks good. Oh, I was going to get this tape off of here while I'm up here. While I'm thinking about it. That's something else to make mention of too. This tape, if you leave it on there for a while and don't take it off when you install it,
it won't come off.
It's going to get harder and harder to remove. So make sure you take it off.
All right, now that we have the wall mount up here, we want to take a look at the connections here, and I'd like to show you by taking the electrical cover panel off here. This one's designed a little bit differently from ones you may have seen. This whole piece comes off and you have easy access to the control board here. You'll notice a couple of additional plugs that we have here. One is for the wired wall controller, and then the other one is for Wi-Fi module. On the 30 and 36K, the Wi-Fi module is not included. You will have to purchase that separately if you want to make the 30 and 36K Wi-Fi capable. All right, so on this, I'm going to be using ring terminals so that we have a nice clean look. And we've got a good connection on these. So the wires don't really know what color they are, but we need to know that they're the same indoor and out. Right, Greg?
Absolutely. Whatever wire you got on one has to be on one outside. Whatever wire you have on two has to be on two outside.
Right.
And whatever wire you have on three has to be on three outside. The reason being is 1 and 3 is your line voltage, but 1 and 2 work together for communication. So even though it's 230 volts, if you switch the phase, let's say, of 1 and 2 or 1 and 3 from outside to inside, the communication will not function.
Now the important part of putting these ring terminals on here is making sure that you crimp the correct side. So you don't want the nipple going into the top, because that will actually spread apart the crimp. You want the nipple part of that going on the back.
Makes sense? There you are. So while Daniel's doing that, I want to point out something to all of you that I think this will be very beneficial information. When you go to hook up to these mini splits, in case you guys don't know this, these spade connectors or U-channel connectors, whatever you want to call them, they come in different sizes as far as the space between the two forks. So what you want to do is make sure you're getting one that's narrower. As you can see in this one here, the space between those two forks is much narrower than the space between these two forks. And the reason why you want that one that is narrower is because on these mini splits with the terminal blocks, there's not a lot of space in between around the screw to be able to get the terminal up on there. So if you buy these ones that are narrower, you'll have a much easier time getting them underneath the screws on the terminal block, both on the indoor and the outdoor unit. So just kind of a word of the wise in case you guys didn't know that. But using terminals like this is far better than just shoving the wire up underneath the screw. You're going to get a much better connection. And that's why Daniel was using them up there on that wall mount.
That's an excellent point, Greg. You know, there's nothing more frustrating than having to get the pliers out and manipulate the forks to fit around what you're trying to do.
Yep, and those should slide right on for you. So
I'm using green for ground, using black on 3 because that's our main power. It's one leg of 230, but 3 is power alone.
right.
And then 2 is white for communication, and then red is our other leg of power. So, as Greg was saying, the 1 and 2 is used as communication, whereas 2 is your dedicated communication wire.
So if I was going to have to hook a condensate pump up to this, Daniel, which wire do I break for the float?
So if you want to hook up a condensate pump, you want to break 3. And the reason is because if you break 3, the unit shuts down. You can break 1, but the unit's going to sit there and beep.
Okay.
It's going to do the same thing if for whatever reason there's a break in the wire or you just don't have the proper voltage. If there's no voltage on 3, then it's not going to do anything. If there's no voltage on 1, let's say for instance you outside L1, L2, you've only got 120 on L1, the unit would sit here and beep.
Okay.
So
it'd still shut it down if I broke 1.
it'll shut it down. It won't work anymore, but it'll beep until the service technician gets there.
Yeah.
So not the best idea.
3 would just be broke and not making noise. I get it.
Right.
Okay. Fair enough.
And any type of accessory that you want to install, whether it be a UV light or whatever it is, you can power it from 1 and 3. That's your 230 volts.
Okay.
Just don't mess with 2.
Good deal.
All right, looks like
So
we're ready to go. We can put this one back together.
On there too?
I do. I like to make sure that these are inside of this clamp. Twist it around here. Put the screw back on.
Okay.
That way it's nice and neat and clean.
We can go ahead and close this unit up so I can start handing panels back up to you.
So you'll notice that each one of these has a different end.
Okay.
So you can't mix up which goes where, which is kind of cool. So.
And, you know, and those things are nice and flexible, so they're easy to manipulate.
Yep. And one neat little trick, if this happens to be kind of, once you turn the unit on, power it up, and these open, then you can turn it off. And when they close, maybe they're not flush. So you can just gently hold them and turn the unit on, and you'll feel a little bit of pressure. Let them go.
And then
That
resets
sets them.
Okay.
That sets them.
Cool.
Yeah. So if you ever have one, you know, just kind of hanging open a little bit when it's supposedly supposed to be closed, we can just leave that like that until we're complete with the job.
Yep. Looks good. All right. Now we can move on to throwing up some hide line and drilling a hole. Man, that looks good, dude. All right, moving along with our installation here, Daniel and I went ahead and ran the line hide and got that all prepped and ready to go. We already have our hole drilled for our line set to go outside. So now we're ready to go ahead and run the refrigerant lines. So we thought that, you know, flaring these down here by the table would be a whole lot easier than flaring it up on the ladder, and we can also give you guys some good tips about flaring. NAVAC was nice enough to give us a power flaring tool that we're going to use in this video. So without further ado, we're going to go ahead and roll with that. One thing I did want to point out though is, you know, as we said earlier, with the installation instructions, the remote and all that kind of stuff, make sure you don't lose that, because that's where your flare nuts are. And even if your line set comes with flare nuts, we recommend you cut that off and go use the flares that come, the flare nuts that come with the equipment.
Right.
Because there is a significant difference in the strength of those flare nuts. And
it's a thicker brass on the flare nuts that come with the unit.
So with that, without further ado, we're going to go ahead and do some flares. So Daniel, I'll let you take off with that one.
All right. So first we want to remove the cap here. Can't tell you how many times I've talked to a contractor, and somehow or another, this ended up inside refrigerant line.
I could believe it.
I don't know about this one, but the little plugs,
yep, the little
a
plugs.
lot easier to lose track of and leave in there. So you want to make sure that you get that out of there. And then, because the factory, the factory could have damaged the pipe when they cut it. You know, they're not that concerned about how this ends up.
Right.
So we want to go ahead and make sure that we cut a piece off of there and just get a good smooth start to this before we deburr it and move on with the flare. So
what Daniel and I were talking about a little bit earlier was, I've noticed that on these smaller lines, like a 1/4-inch line, if you use a smaller tubing cutter, it doesn't leave as big of a burr as using a full-size tubing cutter. So that's why we have the two different tubing cutters out here. And don't over torque it, you know, do it little by little, just like Daniel was just doing. So I think before I'd even do that, Daniel, just my own thought, I'd just go ahead and slide my flare nut on. That way I don't forget to put it on there.
You got a good point, because I do tend to forget those.
Nothing worse than doing the perfect flare and then looking.
And having to redo it.
So if you noticed, I kind of tipped that down so we make sure we're not getting any shavings inside the copper.
All right, so
give it a little love, huh? All right.
Now we're ready to put our flare piece on there. Flare block, that's what they call it.
Yep.
So, and it has a stop. So you want to make sure that you've got the stop in place.
So let's kind of turn that to the camera a little bit so they can see it.
Yep, this stop right here, that makes sure that you got the right depth. So you want the copper up against this stop. And the cool thing about this tool is that when you put it into the block, it's just going to move that out of the way anyway.
So before we actually flare that, let's go ahead and put a drop of oil on that. It's a brand new tool. It's never been used. So one of the things that NAVAC said to me was, hey, make sure that you use a flare gauge and also put a little oil on that flare before you start flaring. Even though it's brand new, it comes pre-lubricated, you just want to make sure you got a good lubrication to it. So we just use a little bit of vacuum pump oil.
And I just put just a drop.
Yeah, it don't take much.
We don't need to make a mess. So. All right, so there we have a very nice flare.
So it looks nice, but we definitely want to check it with a flare gauge and make sure that we got a proper flare. So if the flare is proper, it'll go in and stop just like Daniel's showing there. It won't push all the way through.
But it will go through
the first hole.
The first hole.
There's like a little metal ring in there, you'll see it, where it's supposed to stop. And obviously if it pushes all the way through, the flare is too small. If it won't go in the hole at all, the flare is too big. Right. So I think we're good with that first flare. I don't see any reason why we can't use that.
Ready to go.
The other thing we're going to do too, just to be sure.
That's a great idea. Keep any
Keep anything from
debris
getting
out
in
of
there
there while we're working
there's just-
around.
Quick piece of tape over it. Whoop, that didn't work so good. It's got oil on it.
And I would not use anything but the painter's tape, simply for the fact you don't want a bunch of glue stuck onto the face of your flare.
Yep. Quick little piece of tape on there, just keeps any dirt and debris out of it till we're ready to actually
Electrical
hook it
tape
up.
would be fine too.
All right. And now we'll go ahead and
Do the
prepare
5/8.
and do our 5/8. This one we don't want to bend around as much because we don't want to work hard in the copper.
I'm going to use the small one again. This is actually my favorite. I've
I like
always
the
liked
smaller.
the smaller one.
I have too.
There we go.
There we go.
Now, like you said earlier,
Put the flare nut on.
put this on first. All right. Now we know we hadn't forgotten anything.
I'll tip that down for you again.
All right. All right, we get it in there and check that it's up against the stop on the flare block. Now, before we do this, we got the flare nut on there, right?
Yes, sir.
Okay. So we're ready to go.
You can tell the tool had to work a little harder on that one.
It did. Might have used a little bit of battery. All right, so we'll go ahead and check our flare to make sure we got the right size flare there. All right, so this one's actually a little bit too big to fit into the flare gauge there. Why do you reckon that is, Greg?
Yeah, I think that something could be out of calibration here.
Yeah, could be. Let's check the other gauge to see if we're just a little bit off. Overflared it just a hair. You want to do another one?
Yeah, let's try another one.
Okay. I'm going to use this one this time. Just to see what's different, right?
Yeah, that's why we checked though.
That's exactly why we check. Look at that.
Perfect.
That is a perfect flare. So on the flare tool, it has some instructions here, and the last instruction says to adjust flare size, loosen or tighten the hex nut here. So it just took, basically, you know, the first time that we turned it, it didn't really make a difference.
Right.
And then we decided to really turn it a lot to, you know, from one, basically a full half turn.
Right.
Which took us way low. And then as we worked our way back up, and we had to adjust a little bit. So just small increments adjusting the hex nut is going to give you a pretty, you know, pretty big size difference. So as you can see, you know, it's important to use the flare gauge so that we know that our tool is doing what it's supposed to be doing.
Right.
Right.
Absolutely. I mean, I like the fact that this is adjustable.
Yeah.
But this more goes to show that you need to use a flare gauge to make sure the tool, whatever flare tool you're using, it could be all about how you set it in the block. It could be the adjustment to the tool. Regardless of what caused the error, you have to use the flare gauge to make sure that flare is correct. Because once you do that, if you use the flare gauge, that's going to ensure you, okay, we made a proper flare, and as long as we torque that to specifications, we shouldn't have any leak problems. But if you just see, if we went with our original one, which wouldn't even fit in there, chances are we were going to have problems. Another thing then if you're too small, you're probably most likely definitely going to have a leak.
Oh, most certainly.
So just goes to show, guys, as you can see here, and I'm going to kind of show all this.
So a recent test unit that I received back, they were having some issues with it and were unable to solve it on the job. So they sent it back to me, and there is red Loctite on the fittings where the line set connected.
We're learning too, you know, as far as adjusting the tool. We took the time to make sure that tool was flaring to the right specification according to that gauge. I'm glad we did this down here and not up on the ladder.
So yeah, I mean, you know, making sure that you have the right size flare, not using stuff like red Loctite. Red Loctite does nothing for it. That's not how a flare works, or any other type of pipe sealant. If we make a proper flare, then we won't have to worry about this when we. And
then one other thing I wanted to point out here is, you know, Navac sends a real nice flare gauge with the tool. The only reason we were using the CPS just because it shows it better with the color for camera purposes. But I really don't care which one you use, as long as you're using a good quality flare gauge to make sure your flare is proper.
Right.
So, all right. With that, I guess we can start planning and running our refrigerant lines.
All right. So up here on the line connections where we're going to be putting our flares for the indoor unit, we already checked this before we mounted the wall mount unit up here, but the unit comes with nitrogen in the coil. So these have little tips here, and if you're able to push that in on either side, then it tells you that you've lost your nitrogen charge. Now at that point, go ahead and reach out to us. I would not recommend installing one that does not have pressure on it. So at this point, we're going to go ahead and release the nitrogen from this. So I've got my channel locks. I always use a backup wrench on this just to make sure that we don't twist the copper.
Daniel, if anything, I might be a little long on you, but we can cut that off and reflare it if we absolutely have to.
Okay, that's fine. Very nice bend.
I like it.
Looks good.
And see what that does to you for your flare nut now. I got this.
Okay. So, can you move?
And yeah, it can go towards you.
So we've got plenty over here. Let me take the blue tape off and go ahead and get this.
I just want to make sure once you're connected that I'm going to stay in my line hide.
Right. So I'm going to take a little bit of just a drop of vacuum oil and put on these threads.
Also put a drop on the pipe so that your flare nut spins.
And it's on the back side of the flare.
Yep, back side of the flare.
So that your flare nut spins on there instead of catching and twisting the pipe.
How you doing?
Let's see.
I just want to make sure I'm going to stay in my line hide. Is that going to be okay for you?
So we've about got it connected there, but you're going to need to push that up, right? So.
Yeah, I think we'll be fine.
Okay, as long as we can get the drain line underneath it.
Yeah,
on
we'll
that
be
bend,
able to.
We're good.
All right, so before you finish connecting that, let me get the tape and get this all taped back up. So I can't stress that enough, that you absolutely want to use a tubing bender on that. I know you guys like to hand bend pipe, but I'm going to tell you, these mini splits are not tolerable to any kind of kink. They are not tolerable to oval pipe, and it's not so much in cooling mode, it's in heating mode, because that now becomes your discharge line.
Because the GREE units are able to heat down to negative 22 and negative 31, we've got a lot higher pressures that we're dealing with. If you got a restriction in a pipe and high pressure, it's not going to go well for the system.
Tape it. I didn't quite get all the way around with my tape. As you can tell, I'm not pressing real hard with the tape either. I'm not pulling it real tight. keeping that insulation loose around that pipe, same as it comes, you know, without it being taped and cut. Because you don't want to press against that copper pipe real hard because it'll cause the insulation to sweat. Make sure I got it all the way around. All right, I got this. If you want to go ahead and complete and do your flare.
All right. We're going to use our torque wrench. This is probably the most important part of making sure that we don't have any leaks on the flares. Next to making sure that it's, you know, checked with the flare gauge. So we always want to use a backup wrench. I've got a torque wrench here, electronic one, and I have it set for 65 Newton meters, which is what the flare, the install manual shows for the flare, the 5/8 flare. I'll put my backup wrench on this side. I've got the adjustable wrench snug, and then tighten it up. I like on this one, it buzzes when you hit your target. So it gives you a beep when you get close, and then it buzzes when you hit it.
Good job.
All right.
So we don't want to pull that insulation up yet or anything. We will insulate that nut and get all that taken care of, but we don't want to do that until after we do our leak check. But Daniel, why don't we go ahead and do one of those zip ties just to kind of pull that pipe in. Don't pull the zip tie tight yet, just to kind of hold it up there.
There you go.
And then we can work this line down. So now we need to measure off about 4 feet of pipe. And then we can cut it off because that's all we're going to need outside. So if you just go ahead and roll this out on the ground and give us, you know, to where, let me pull this bag out of here that we had. Just give me about 4 feet of pipe, and here you can, I'll give you the razor knife and you can cut that insulation off.
Double check where we're at.
You said you need about 4 feet.
Okay, right there's good.
All right, so what I did is I kind of laid that line set down, and I wanted to make sure roughly in the center of that hole where my 90 needed to be, and I put a mark in the pipe knowing that that was going to be the center of my bend. So just double checking, making sure we're on 5/8, and we are. And we want to do this bend straight back toward the wall. All right? Mm-hmm. Let's kind of bring this out a little bit more so we get a nice, you know, what we would consider a 90-degree bend. I don't want to overdo it, so I'm going to stop right there. Break her loose. Sometimes you got to wiggle her back and forth to get the bender back off. There we go. Let you grab that. Kind of bring it forward.
Yep. All right, we got it. Should be good.
Okay. And then I need to push this up.
Got to go that direction. Yeah, about right there.
Okay.
And take our cap off of the indoor unit here. make sure you use a backup wrench so we don't twist the 1/4 inch copper, because it is really easy to twist.
Yep.
Take our blue tape off of there. We'll put a little bit just here of oil.
Same 2 locations, 1 drop on the threads, and then 1 drop on the pipes so the flare nut don't hang up. On the back side of the flare.
And with the 1/4 inch, you want to make sure that it's as straight as possible towards the flare when you're tightening it up, hand tight. All right, and then I'm going to set my torque wrench. And the 1/4 inch is going to be 18 Newton meters. Make sure we use our backup wrench on this. That's it.
Yeah, I heard it beep, and then I heard it vibrate when you got where you were supposed to be.
Yep.
So I'm going to cut this insulation loose again. I want the center of my bend to be right there. I don't want that to be center. Give me a 90-degree bend on that. That looks pretty good.
Good.
So I know a lot of you guys out there be like, man, that's 1/4 inch. You can bend that by hand. Again, I want to go back to what I said earlier. These machines do not tolerate ovaled out pipes. They don't tolerate kinked pipes. So I'm going to tell you the best thing for you to do is always use a bender on every single bend. Take that one like so. I think if I cut a little of this out,
No, don't do that.
It'll allow me to bring it around and tape it.
Getting the insulation around the bend and then making the joint next to it.
I'm going to zip tie these 2 together. All right, we are ready to move on and get the line outside. The center of my bend.
Right there.
Yep.
Just keep a hold of that elbow
You want to
while you're doing it.
You want to straighten this out and slide her through? Stay to the left. I'm going to go out there and keep that from going in the ground.
Okay. All right. Good. We are feeding the wire through the wall. Good?
Yeah, that's all I need out here.
Okay.
Zip tie or 2 around it just to kind of hold it.
Put a little bit of a fall with the level on the line hide when we put this up here. Just to give it a little bit of gravity drain. We don't want to go the opposite direction clearly. but we didn't want to leave it just horizontal. We want to give it a little bit of flow.
I'd say we gave it at least 1/4 inch per foot.
Yeah.
All right, I'll put a little piece of tape on there just so that can't ever pull loose. All right. I'm gonna wait and not zip tie all this till after we leak check and get these wrapped.
Perfect. I'm going to go ahead and put a zip tie in here just to keep this wire held up here.
So we want to definitely make sure we lose that.
The bonnet.
Yep.
Well, I do like to save these.
Oh, you save it, but you want to make sure it's on for your line set.
Correct.
I'm just going to whack this off. That way I don't got to try to peel the tape off. Then I'll get this figured out where I want it. My flare nut. Slide that back. Grab that tubing cutter. That works pretty slick, don't it?
It's ready to go when you are. Got you a marker.
Let's see how I did. Perfect flare.
All right, so our adjustment held.
Yep. For the 5/8.
We'll find out on the quarter.
1 drop of oil on the threads, 1 on the back side of the flare. Smear that around. Smear that around. Get a pipe up on there. I want to make sure that that's not going to cross thread or anything. We're just going to turn it with a regular wrench to start with, just to make sure she's going on smooth and free. Alright, again, we're going to use the backup wrench. There we go. I felt the vibration. There we go. Alright, that takes care of that one. I think I left enough slack in that I can get that pulled down nice and neat looking.
Looks good.
Once I get the other one hooked up. Alright. Now the 1/4 inch pipe. I'm going to go ahead and take that flare nut off. Slide the flare nut on. Yep. Thank you, sir. We're good.
Good flare?
Yep.
All right.
Flare. One little drop of oil on the backside. One little top of my threads. Smear that around. Smear that around. Set that on there. Put that nut down. We're good.
Heard it vibrate.
Yes, sir.
All right. So now our
refrigerant lines are all hooked up, so now we're ready for a pressure test.
All right.
All right, so what we're doing here is we're ready to hook up nitrogen tank and charge this thing up and do a little leak testing. What would you recommend for pressure?
I'm looking somewhere between 350 to 450.
Okay.
It's perfectly fine. These systems, the high pressure switch doesn't cut out to 610 psi. So we're fine to get some good pressure on there to see that we, confirm that we do not have a leak. We can get some bubbles on there, and if there is a leak, if we have 400 psi on there, we're going to see it, right?
Sounds good to me. We're 168 so far.
And I like the way that you're kind of slowly bringing it up instead of just putting the pressure on there and seeing if you have a leak.
Yeah, I'm just giving it a minute. I'm going to let it sit now. I'm at 205 pounds. Just give it a second and see if it drops any.
All right, so we're going to use the big blue here on the inside and just soak these joints real good. I like to get the back side of the flare as well. Right back here. I like to have a paper towel with me when I'm soaping these joints just to make sure that they don't get soaped down the wall and all over the place, especially if I'm on the interior of the home. And I see no bubbles, so we are good. I'm going to go ahead and tidy this up a little bit. And we'll check back in with Greg outside and see if we're holding pressure.
So I wanted to point out on the adapter for the micron gauge that we want to hook this up on the core removal tool here. We need to make sure we're using the Schrader depressor side because the side access port on the core removal tool does have a Schrader in it. So I'll go ahead and get that hooked up. Try to turn this, hopefully where we'll be able to see the micron gauge pretty good. Turn that on. All right, looks like all our hoses are good there. So now we'll get the vacuum pump hooked up. Ideally, you wouldn't want your micron gauge so close to where you're pulling vacuum. But since we only have one access port on a mini split, we really just don't have much choice. So we have to work with what we got. This hose hooked up on the vacuum pump. Make sure we got a good connection. I'm going to open the ballast just a little bit on the vacuum pump. Turn the pump on. Open that up. Close the ballast down. Let her suck away. Pulling down pretty good so far. Nowhere near where we need to be, but we're making progress here. We've got a lot of moisture in the air and stuff, so I'm sure that's why this thing's, you know, taking a little
Bouncing
longer.
around a little bit.
Yeah. You know, it's inevitable. Your moisture got up in that pipe, even though we bled some nitrogen through it. I say it got all the way down to 322, and then it bounced back up again. I noticed that. And it's just, you know, the volume between the refrigerant lines, the indoor coil, and all of that. You know, just got to let it run, do its thing. I mean, we're within specifications as long as we stay under 500. But there's no such thing as making a system too dry. So, like I said, I'm just going to let it run for a few more minutes. Let's see how low it goes. You mentioned a little while ago about, you know, you've heard people say, well, I read in a vacuum pump for 30 minutes, and I've heard people say overnight, and it's like, okay, well, that tells you nothing. Because if you had moisture in there, if you had a small leak, it doesn't matter. You never proved that you actually had that refrigerant circuit in a void.
Right.
And a gauge doesn't measure that. Because, you know, what is it, I think it's like 760,000 microns is atmospheric pressure. Mm-hmm. And you're pulling down to under 500 microns.
Right. Big difference.
That's a huge difference in, you know, what atmospheric pressure is and what we need inside those pipes.
Right. Did you hear the tone of the vacuum pump change?
I did.
As it's getting lower, the tone's changing?
Well, I've actually had people tell me, well, you can just listen to the tone of the vacuum pump, then you know whether or not you're in a deep vacuum. I'm sorry, but it's still not the same as measuring it with the right instrument.
It's not the same as seeing on the vacuum gauge what the micron actually is.
But I think we're down to 162.
Yeah, that's looking pretty good.
And since I'm using a cordless vacuum pump, I think I'm about ready to go ahead and valve it off, make sure it holds.
Sounds good.
So I started my stopwatch, kind of watch how long, see where we kind of level out at. Make sure we don't rise above. You know, industry standards pull it down to 500. As long as you don't rise over 1,000 and it stops, you're fine. But if you got a good dry system, you probably ought to be able to rise up no higher than 500 and stop and stay. So we're into it for a little over 2 minutes. We've rose up to 387, which is still well within the decay test. Right now we're holding at 406 microns for 5 minutes and 36 seconds. We've held under 500 microns for well over 10 minutes now. Yeah. We're at 425 microns, and we can get another shot at that right around there. So the next step that I like to do is I'm going to have to unhook the vacuum gauge. I'm going to have to unhook the vacuum pump.
Right.
With this particular installation, we stayed within the 25 feet. We don't need to add any additional refrigerant. But I don't want to put a valve core back in a vacuum. So what I will do is take a gauge hose and gauge and just put enough pressure in there to break the vacuum. It might only be 3 or 4 or 5 pounds of pressure, and it's just going to be vapor,
PSI.
No liquid.
Right.
So that way, then I can put the valve core back in, and it's pressure to pressure instead of me trying to shove a valve core back in with the core removal tool with it being in a vacuum, because I'm afraid that little split second there, you're going to get a little air in that system. So I've always done pressure to pressure whenever I mess with valve cores. I never really want to try to change a valve core.
You don't want to do it under
a vacuum. So anyway, I just wanted to kind of explain to you all what the next step was and where I was going to be going with all this.
Right.
Like I said, I don't need to add any additional charge. I don't want to put liquid in it. Just a little bit of vapor pressure so that when I slide that valve core back in, it'll be pressure to pressure. But as far as I'm concerned, we're at 429 microns. We'll get another little shot of that real quick, and then we'll keep the camera there, and you kind of see what I'm doing, getting the gauge hooked up and just putting a little bit of pressure to it.
All right, so, perfect.
All right, so we're going to move on.
Let's get another look at the micron gauge.
Yep.
And then we'll go from there.
All right, sounds good. And we've been into it for almost 15 minutes, holding vacuum.
Under 500.
I put a little more in there than I wanted, but that's not going to hurt anything. It's just a little vapor pressure. So I just wanted to make sure I didn't have any possibility of me getting air when I put the valve core in there. So now I can valve that off, disconnect my hose, grab my valve core, leave a little of this pressure off. Kind of upside down for the camera, but I just got 26 pounds in there, which is plenty good. And this should allow me to get my valve core back up in there. And that little bit of vapor pressure I put in there ain't going to affect the charge on this machine at all. So we're good. All right, now we are ready to open the service valves.
Now the reason I didn't get my service wrench is because it will fit the 1/4 inch valve, but it will not fit the other valve because the 1/4 inch Allen is a little bit too long usually.
These are pretty easy to open. A regular Allen key works just fine. With that, we got 152 pounds. So we're ready to run this machine. Should be ready to go. All right, I think we completed our vacuum. We got pressure on the system now. We did our leak check. We're ready to move forward with some electrical wiring. We didn't show you the entire installation of the disconnect in ICM 493. So first of all, the electricians had already come out and wired a disconnect and had it set up for us. The breaker's off. The breaker panel's in the garage and the breaker's off to it right now. But anyway, we went ahead and installed the whip going from there to the ICM 493. The ICM 493 is a surge protector along with voltage monitoring, which we will show you the setup of that board. But I wanted you guys to be able to get a view of how this hooks in. So your disconnect is your main power, comes into your disconnect. You leave on your load side from your disconnect. You go into the ICM 493, then out of the ICM 493 into the unit itself. So just wanted to make sure you guys got a good shot of the ICM 493 and the disconnect all being wired up. Also, there is a fuse on this board in the ICM 493 as well, just in case you ever have come out to look at one or whatever. You'll know that that fuse is in there, and you can find other YouTube videos and information from ICM itself about these ICM 493 boards. So without further ado, I'm going to go ahead and close this disconnect up and rotate that board up in there. So that's actually kind of cool. This just kind of rotates up into there, and there's a screw that holds it in place. So I will get that all done in just a minute here. And then since I'm not going to be rotating anymore, I'll go ahead and tighten these side screws up a little bit. That part is done. Now we can move forward to actually hooking up the unit itself. All right, so before I close up this electric panel, I just wanted to give you guys the opportunity to get a look at the connection. So we got our power connections done. I did use those little fork terminals. It's like what I like to call them. I don't know the technical term. Because it gives you a good solid connection. You're not just slipping a stranded wire under the screw. So it takes a couple extra minutes to use those, but I highly recommend them. I used them for the grounds. I also used them for power, and I also used them for the 14.4. So now that's all connected up. Before I actually applied power to the system, I'm going to go ahead and roll them wires up inside there and put that panel back on. And then we're going to get power applied. And then once we're done with that, while we're doing that, while we got power up to it, we'll go ahead and go through this ICM 493 and tell you more about it and explain to you the setup procedure and all that. So without further ado, I'm going to go ahead and put this panel on here. Up in there, tip that up in there. Good deal.
So we have the ICM 493 here powered up, and we're going to just show you the settings real quick. So it cycles through information, and it'll tell you how many of the MOVs, which are the surge protector banks. It'll tell you how many is good, and it tells you the current voltage reading, which is 254, 253. Okay, so when you go into setup, you see we've got our line voltage set to 232. We can adjust that, and then go to the next setting, and this is our over-under voltage protection. We can do 1 through 10%. So the calculation that Greg and I come up with was at 232 plus or minus 10%, that puts us at 255 on our high end. So that'll keep us from going over that 255 volts.
Right.
Which is good protection for the GREE system. So let me go back into it here. So line voltage, and then our over under voltage. We have an anti-short delay, which is the recommended is 4 minutes. You can adjust that. That is when the contactor opens, how long before it re-engages and sends power back to the unit. And then it's got a reset mode, which we don't adjust, and then allowed MOV failures. So we set it to 3. If you set it to 4, then if it's exhausted its ability to surge protect, it will continue powering the piece of equipment. So there's a chance you could lose a board if there was another power surge. So we set it to 3 just to be safe, so that it will not power the unit after it has had 3 of the MOVs failed due to a surge.
So if you have high voltage surges, we know that's a big component to the board failures on GREE units.
Right.
So, but also with the voltage monitoring, there's times where your voltage can really be high. It's not really a spike, and you just want to kind of protect that unit from having voltage, that unit's from seeing voltage that high.
Right.
255 volts is still a little on the high side.
It is.
But I don't think at 255 volts we're going to hurt this unit. So, and the voltage here is already riding around 253. We were seeing that, which is on the higher end.
Right.
So, but, you know, where this home is located, it makes sense to me because he's toward the end of the power line. As more homes start building up here, I would expect that voltage to come down some. But right now, he is on the higher end of that voltage. And, you know, I've talked to many contractors on the phone. They can call the power company all you want. They ain't going to do anything about it.
Nothing's going to happen about it. Yeah, they're not going to do anything.
So
this is good to have, especially in this location.
So the surge protection is what actually keeps it from, if you get the power surge, it's going to cut off power to the unit, keep us from damaging the board. The voltage protection is, hey, we're going to open the contactor here because we're not liking this voltage being this high.
Right. Or too low.
Or too low. So, and we set it, we were plus or minus
10% of 232 volts. So now that we've explained the ICM 493, we've got everything hooked up and ready to start pretty much. We've got a little bit of installation that we have to fix. So now that we have the power on the system, we want to make sure that we give the crankcase heater time to warm up. So we're going to go get some lunch, and we'll be back and ready to start the system.
All right, everyone. So we appreciate you tuning in to our little installation video to try and give you some tech tips about, just things that we should be mindful of when we're installing one of these units. And I think we pointed out a lot of good information there. In case you're wondering why we're standing right here in front of this wall mount, is because we are a little chilly.
It's toasty.
And it is very warm.
I'm about to have to take my jacket off.
It feels really good. So, and as you can see here, so we got the unit right behind us running inside the garage, and we also have the condenser running outside. And so we just still got a few things to button up. We got to put the line height on. We got to insulate that line set where we didn't insulate around the flare nuts on the inside unit. Hook the drain line up outside, do a little tidy up outside, but everything's all set up. It's functioning well. It's nice and toasty warm blowing on our backs.
Working great even with the garage door open here.
Since we've been working in the rain and everything, this is actually was a nice little treat to get a little warm blow on the back of us.
So what do you think, Jim? Does it feel good?
It feels great. I love it. I'll be able to come out here now and enjoy the warmth. I like to do some projects out here, and it gets a little too cold or too hot. And I also have a hot water heater over there with some pipes that I'm a little worried about freezing.
Well, I can tell you for one thing's for sure, I have a mini split in my garage, and I absolutely love it when I can go out there in the wintertime, and it's actually comfortable, and you can work on little projects and stuff. And Jim, I think you will enjoy it just as well as I do. With that, we're going to sign out, and hopefully you guys will enjoy this when we do the Tech 90 coming up.
And don't forget, with GREE, we're by your side.
If it's okay with you, maybe after you get to utilize it for a little while, we'll come back and do a little video shoot with you and your wife, and just you can tell us what you think about it.
Sounds good.